Hello everyone, welcome to the channel Understanding.Concepts.Of.Physics. Today we have been given this one problem of oscillation wherein they have given you the displacement of x is equal to a sine omega t plus b cos omega t, and they are saying us to prove that this particle is in SHM and the amplitude is this. So let's just quickly derive this. This problem is going to take a while, so maybe this question can come for 3 marks. Maybe it is not deserving 2 marks, but yes, you definitely, if the entire question comes, it will come for 3 marks. If a part of the question comes, it can always come for 2 marks. So there are two aspects of this question. We are supposed to prove that this particle is in simple harmonic motion, and second, the amplitude is equal to root of a square plus b square. So let's just see how to crack the problem. If I want to prove that a particle is in simple harmonic motion, I need to prove that the force is directly proportional to the displacement, and it is always pointing towards the mean position, or it is always opposite to the displacement. So if I want force, I will have to find out acceleration. For finding out acceleration, we have to find out velocity, and for finding out velocity, I have to have a displacement. So displacement is given to you. If you differentiate this, you will get velocity. If you differentiate this, you will get acceleration, and if you multiply mass to acceleration, you get force. So this is the way how we are going to do it. So displacement, you will have to differentiate it twice to get acceleration. So let's just quickly start. So x is equal to a sine omega t plus b cos omega t. This is the equation. I have differentiated this, and I am assuming that you have some knowledge of differentiation. So there is dx by dt, and if you see this equation, a is a constant that is thrown outside, and derivative of sine is cos of omega t. But there is a chain rule because there is a function inside a function, so we should always keep the derivative of the inner function again. Same way, b is a constant outside, and derivative of cos is minus sine. So sine is written and minus is thrown outside. So if you remember, if you see this is plus and this is minus. So b sine omega t, and because there is a chain rule, I will just write a derivative of omega t again. Now as you know that derivative of 4x is equal to 4, we can say that derivative of omega t is equal to omega. So this will remain as omega. So this entire thing will yield me omega. Now this omega, I am just writing it over here. Same way, derivative of omega t will yield me omega, and this omega I am writing it over here. So my next step represents the same thing. A omega cos omega t minus b omega sin omega t, and derivative of displacement will give me velocity. Let's just differentiate this further again to get acceleration. So differentiating with respect to t will give me dv by dt, and which is equal to, now again, a omega is a constant, I have thrown it outside. Derivative of cos is minus sin omega t, and again I'll have to apply the chain rule, so d by dt of omega t. Now the derivative of omega t is again giving me omega, so this entire thing will give me omega, and this omega I'll multiply this to this previous omega. So omega into omega will give me omega square. So finally I get minus a omega square sin omega t minus, now let's see for this one, minus as it is, b as it is. Now omega also as it is, but there is an omega square. How does omega square come? Derivative of sine is cos, so that is cos omega t, and there is a chain rule over here, so d by dt of omega t. Now the entire thing, derivative of omega t will give me omega, and that omega I will write it further ahead, and that omega and the previous omega, this one, will give me omega square. So this is the way how we differentiate it with time again. Now dv by dt is nothing but acceleration, and acceleration is equal to minus of, now here in this step, what I am doing is I am taking out omega square and minus common outside. So minus omega square is thrown outside, and what remains is a sin omega t, and because I am pulling out minus from inside, I'll have to change the sign from inside. So this becomes plus, and this also becomes plus. Omega square is gone outside, so what remains is b cos omega t, and if you see this square bracketed term, this is nothing but equal to x, which was given already. So in place of this box, I'll write as an x. So I got acceleration, and acceleration is equal to minus omega square x. So I'm multiplying this by mass, multiplying this on both the sides. Mass into acceleration is force, and which is equal to, now this is m and omega are constants, and in placing two constant, we'll write only single constant, we'll write as k. And if you remove this constant, this equal to will become proportionality sign, and which says that force is directly proportional to displacement, and they both are in opposite direction. And whenever this happens, that we can say that the particle is in simple harmonic motion. This is the first part of doing that, whether the particle is in simple harmonic motion or no. And the last part is that the amplitude is equal to root of a square plus b square, the resultant amplitude. So let's just quickly do that. So I am comparing my given equation that with x is equal to x1 plus x2. So this equation which was given to us, this equation, I am comparing this with x is equal to x1 plus x2. That implies that this term is equivalent and this term is equivalent. So x1 is equal to a1 sine omega t and x2 is equal to b cos omega t. So my equation is x1 plus x2, and in place of x1 I have a sine omega t. This is from what the equation is given in this question. However, if you remember the formula when we did composition of two SHMs, in case you have not watched that, you should go and watch the composition of two SHMs. In that formula, we have used a equation x1 is equal to a1 sine omega t plus alpha 1. This is our equation which is I have written over here. So I can compare these two equations. I can say that a1 is a and alpha 1 is 0 because there is nothing over here. So I can say that plus of 0. So alpha 1 is equal to 0 and a1 is equal to a. And same way x2 from the given question I can write as b cos omega t, and cos I need to replace it by sine. So cos can always be turned out to be omega t plus pi by 2. Now this is not a video where I can explain you this how the cos converts to sine. It will take another proper video in order to make you understand how cos comes out to be sine. So we are not focusing on that part. Yes, some math trick, some trigonometry trick can give you this thing. But remember that cos can always be converted to sine by adding a pi by 2. Now this is something which I have manipulated with my question. Now the thing which we learnt in our article, we said that x2 is equal to a2 sine omega t plus alpha 2. So alpha 2, in place of alpha 2 we have pi by 2 and in place of a2 we have b. So I have got the values of a1, a2, alpha 1, alpha 2. Now my resultant amplitude ka formula is root of this a1 square plus a2 square plus 2a1 a2 cos of alpha 1 minus alpha 2. Now we'll put up the values of a1 a2 and alpha 1 alpha 2 and a1 a2. So in place of a1 there is a, in place of a2 there is b, in place of a1 it is a, in place of a2 it is b, and in place of alpha 1 it is 0, and in place of alpha 2 it is pi by 2. You just have to compare these two equations, and you will get these values. Later on 0 minus pi by 2 is minus pi by 2, so I'll get 0 minus pi by 2 as cos of minus pi by 2, and cos of minus pi by 2 is again equal to 0. Okay, like how cos 90 is 0, cos minus 90 is also 0. So this entire term is having a value of 0. So 0 into anything will give me 0. So this just cancels off, and what remains is a is equal to root of a square plus b square. This is what they are supposed to prove, whether they were asking us to prove, and this is what we have done. So I hope you have understood this question and answers solution of that. Hope you enjoyed the video. Subscribe the channel in case you have not done so, and keep watching the video from the playlist. Thank you so much. Have a nice day. Bye.